Hey everyone, this is Raja from Charger Games and welcome to this Unity C# scripting video. So this video is part of my complete Unity C# scripting course, which is a 25 plus hours long video course, and you can take a look at the full course from the link in the description below. So I hope you will enjoy this video. So enjoy the video, keep learning, and let's get started. Hi there and welcome to this video. My name is Raja from Charger Games, and starting from this video we're gonna learn about C# scripting for Unity game development. So now since this is the very first video, so in this video we're gonna discuss a little bit background about C# and Unity and how these things work. Okay, so let's get started. Now whenever you want to build games, you actually have to give some behaviors to your objects. So let's say you have a player. So you definitely want your player to be controlled by the player. So the player in your game should be controlled by the player who is playing the game. Or let's say if you have a gun, you want to fire bullets from the gun whenever you press certain keys. Now to do all these things, you definitely need to add some behaviors to your games. So let's say you have a 3D model of a car, but you have to move the car. So if you want to move the car, only creating the 3D model is not sufficient. You have to add some behaviors so that you can move the car, rotate the car, and you can control the car by pressing left and right arrow keys. So to do that, we can write scripts in Unity and attach them to specific game objects to add specific behaviors to them. Okay? So whenever we want to add some specific behaviors, we have to create specific scripts for that specific behavior and we need to attach that to that game object. Okay. Now in Unity, we mainly use the C# language as the scripting language. Now some of you might, who are new, might actually pronounce it as C#, but it's not actually C#, it's called C#. Okay. So previously Unity supported JavaScript, a form of JavaScript which was known as UnityScript, and there was also another language called Boo, which was a different version of Python, but currently it mainly supports C#. So that's what we're going to use in this course as well. Now whenever you want to create a new script, you can create it in various different ways. So as you can see, currently I have the Unity editor opened here and I have created a new 3D project. Now if you are not seeing this layout from the beginning, then you can change it from here. You can go to this top right corner, and as you can see, I have selected 2x3 layout here. So you can select that, and if you go to default, you can see the default layout, and probably when you open Unity for the first time, this is what you see. And if you want to go to the 2x3 layout, you can simply click on that and simply go to this 2x3 layout and you'll be here. So now when you're here, you can create scripts by various methods. So what I can do is I can go to this assets folder and right click and create a new folder, and I'm going to name this folder scripts. So whenever you are working in Unity, it's a good idea to organize your projects this way. So now I'm going to go inside this scripts folder, and if I right click here and click on create, as you can see, I can create a new C# script from here. Okay, so if I click on this one, I can create a new C# script. Now another way to create a script is by clicking on this create button here and then clicking on this C# script. So let's say I click on C# script here, and as you can see, a new C# script has been created. Now here you can give a name to the script. So let's say I give it a name to first script and then press enter, and as you can see, our first script has been created. Now when you are creating a new script, you must give it a name at that time, because if you don't give it a name, then the class name of the script will not be created correctly. So let me show it to you with an example. So let's say as here I have this script created, and when you select it, on the right side you can see what is written inside whenever you create it for the first time. Now as you can see here, we have public class first script. So this is the name of the class which we have given here. Now if we don't give it any name and later try to change it from here, then it will give us some errors. Okay, now when you create a script, you need to definitely open it before you can actually edit it and write your own code. So you can double click it, and by default it will open in MonoDevelop or in Visual Studio depending on what editor you have selected. In my case, I have selected MonoDevelop editor, so it will open in MonoDevelop. And if you're not sure which editor you have selected, you can go to this Edit, Preferences, and External Tools. And as you can see, for me here, MonoDevelop is selected. For you, here might be you might have selected Visual Studio by default, so that will probably be selected. And from here, you can change it to any editor you want. Okay, so now let me double click and open it in MonoDevelop. So I'm gonna double click it, and as you can see, it will be opened in MonoDevelop code editor. So you don't need to worry. In your case, it might be opening in Visual Studio, so you don't need to worry about that. You can use that as well. Let me zoom in a little bit. And as you can see, this is the code which is created by default when we create our very first script. Now the things which I was actually saying to you is this name of the class. Whenever you create the script, you give it a name here. As you can see here, we have given the first script name. And when the script was created, as you can see, the name of the class was also first script. Now you need to make sure that both of the names are same. So let's say if I go here and I try to actually rename this script and I change it to something else. So let's say I change it to first script 2. And if I do it, Unity will give me some errors because there will be, as you can see, the script is gone because I have actually changed its name. So this is not the script which we had created before. So now if I double click it, as you can see, a completely new script will open here. Okay. So you need to make sure that both of the names are same. Now, as you can see here, though we have changed the name, but the name of the class is different. So that will not work. So you need to make sure that the class name and the name of the script both are same whenever you are working with it. Okay. So let's say I change it to first script again. And now it will work. Now currently you are not seeing any changes because currently the script is not attached to anything. Now in Unity, the scripts or the codes that you create will not work by themselves. If you want the scripts to work, you have to attach them to something. Okay, you have to attach it to any game object. So let's say in my scene I have a cube and I have written a script which by using which I want the cube to move to the right direction. Now the cube will not directly move. I have to actually attach the script to the cube to make the cube move in the right direction. Okay. So to test that, first of all, let me go ahead and click on create and create an empty game object. And this is the game object to which we're going to attach our script. And only after attaching, our script will start working. Before that, it will never work. So let me go ahead and drag and drop this first script to this here. So that's a way to attach the script. So I can drag and drop it on here. And as you can see, the script will be attached to the game object. And I can select here, select on this gear icon, and from here I can click on remove component, and as you can see, the script is deleted. Another way to add the script is by clicking on this add component and going to this scripts option, and from here, as you can see, the list of scripts that I have. Currently I have only one script, so I'm going to select this first script, and as you can see, it has been attached. Okay. So this is another way to attach the script to this game object. So now that we have attached the script to the game object, now it will show us errors if we make any. So let's say, as you can see here, the name of the script is first script. So if I go to the script and change the first script to first script 2 and click on file save or press Ctrl S. And if I do that and return to Unity, you will see that Unity will give me some errors. And if I click on run, as you can see here, it says the associated script cannot be loaded. Please fix any compile errors and assign a valid script. And it is saying it because the name of the script is not same in the class name and the script name. So this is the most important thing. Whenever you are writing script, you need to make sure that the name is same. Otherwise, whatever code you write, it will never actually work. Okay. And another thing you need to make sure is that whenever you write a script, as you can see, if I click on save now, as you can see the error is gone. And you need to make sure that whenever you attach a script to the game object, if you want the script to work, you need to make sure that this checkbox is checked. And if it is not checked, then the script is not activated. That means whatever behavior you have written inside the script will not actually work. Okay, so you need to make sure that you click on this one. So now let's go here and write our very first code that will actually do something. So what we can do is inside this start function, so this is the code that is created by default, which you're going to learn about in later videos. So inside the start function, inside this thing, we're going to go ahead and write print, and inside it I'm going to give double quotation marks, and inside the double quotation marks I'm going to say Unity is running, and I'm going to close that and give a semicolon. And once we have done that, and if I go back to Unity now, and if I click on run, and as you can see, if I click on run, and as you can see in the console, it says Unity is running. So if I go to window and console, as you can see in the console, it says Unity is running. Okay, this is what we're getting printed whenever we are actually running the game. So if from here I can change it to something, let's say I change it to my first script is running, and then I save the script. And now if I click on run or click on play, as you can see now as you can see, it says my first script is running because we have changed the text here. So this was just for demonstrating how it works, how we can print the console and how we can run our very first script. So in the later videos, we're going to learn more and more about these things. Okay. So let's summarize what we have learned in this video. So in this video, we started by learning what is scripting and why do we need it. Then we have learned how we can create scripts in different ways. Then we have learned how we can attach the scripts to game object, and we have also learned how we can change the name of the script and why we need to make the name same in the editor and in the class as well. And then we have written our very first code, which is running on the Unity console. So this is it for this video. I hope you really enjoyed. From the next video, we're gonna keep learning more and more about this Unity C# scripting. So this is Raja from Charger Games, and I'm gonna see you in the next videos. Thanks for watching. Hi there and welcome back to this video. This is Raja from Charger Games. So in the last video, we have learned about the basic of scripting and how we can add a script. So as you can see, this is the script we have created, and we have also learned that if we change the name of the script, let's say I change the name of the script to first script 2 and then save it. And now from the game object, as you can see, we have this first script attached. So now if we try to remove it, and then if we try to attach it one more time, as you can see, it cannot attach. That's because the name of the script here, which is first script, and name of the class here, which is first script 2, are not the same. So if both of them are not the same, then we cannot use this script. Okay, so we need to make sure that both of the names are same. So let me remove this 2, save it, and now again attach it, and it will attach successfully, as you will see. Okay, so done. So in this video, what we're gonna do is we're gonna learn about the basic structure of the script that we have created. Okay, so let's get started. So as you can see, when you create your first script in Unity, this is what gets created, and you see all these things and you get confused because you don't know what these things mean. So in this video, I'll try to clarify what these things mean in short. So let's start from this. So as we have learned, when you create a new script, what Unity C# does is it creates a new class for you. Now C# is an object-oriented programming language, and in object-oriented programming language, class is the basic thing. A class is the class is the blueprint or the basic structure of the object. Okay, so this class will define how our behaviors to our objects will be, and to whatever thing we're gonna attach this class, that object will behave like that. Okay, So as you can see here, it says public class fruit script, first script. So this is the name of the script and this is the name of the class. And as you can see, this is the curly brace. It starts from here and this is where it ends. So from here to here, all this thing, this is the body of the class. So whatever we're gonna write inside this will be part of this class, okay? But anything that we write outside of it, let's say I write something, I write a function here, I write void start here again, but that will not be part of this class. So anything that's inside this is part of this class, okay? So now, as you can see on top, you can see something called using Unity system.collections, using system.collections as generic, and using Unity engine. So what are these things? So these things are known as namespaces. In C#, there's a concept called namespace that pretty much means every programming language has some built-in libraries or some built-in functions or methods or classes which are ready for us users to use. So in this case as well, Unity has created a lot of inbuilt methods, inbuilt functions, inbuilt classes that we can use anytime in our game. Okay, so for our own benefit, they have created those classes which are ready to use. And then they have included those classes inside some specific namespaces to organize them. Okay, so let's say the basic functions or the basic classes that we can use are inside this using Unity engine namespace. Okay, so everything that is specific to Unity are inside this Unity engine namespace. Now let's say we are going to use something for the user interface. Let's say we are going to create some buttons. We are going to create some what can I say, progress bars. So for those things, for using those things, the code that Unity has created are inside another namespace that and to use that we need to write using Unity engine.ui. Okay, so this means user interface. This UI means user interface. So when we are going to use the classes or the codes that Unity have created specific for being used in UI, we're going to use this using Unity engine UI namespace. And when we say using Unity engine.ui, we are telling Unity that we are ready to use any class from this and allow us to use the classes from this. Okay. So in this case, as you can see, we have written using Unity engine. So this is the main namespace that you're going to use in almost every of our script, every script that we write. Okay, because most of the things that we use in our script are part of this Unity engine namespace. As you can see here, it says public plus first script, and then it says something called mono behavior. Okay, so this mono behavior is the base class to all the classes that Unity has created for us. Okay, so anything that we're going to use from Unity are part of this mono behavior class. So here, as you can see, we are writing colon and then we are writing mono behavior. This feature is known as inheritance. This feature is known as inheritance. Inheritance means we are inheriting all the behaviors of a class to our own class. Okay, so if we want to use all the behaviors that Unity has created for us, and then if we want to use them in our own game, then we need to inherit from this mono behavior class. Otherwise, we will not be able to use them. Now we can go ahead and delete this mono behavior. Let's go and do that. Then we can of course write the code. But as you can see here, the print method, the print function has become red. That means there is no print outside of this mono behavior. So if we want to use the specific code that Unity has written for us, then we need to include this mono behavior here. Oops. Okay. Otherwise, we will not be able to use the code that Unity has written for us and use in our own classes. Okay. So this is what you need to use when you want to use the code written by Unity in your own script. Now let's go back to namespaces. As I have said that everything that Unity has created for us is inside this Unity engine namespace. So this mono behavior class is also inside this Unity engine namespace. So let's go ahead and delete this Unity engine namespace and let's see what happens. So if I go ahead and delete it, oops, not like this. Okay, as you can see, I have deleted this one, and now as you can see, this mono behavior is in red color. That means it's error, and it says that the name mono behavior does not exist in current context. Okay, so as I have said, if I just bring it back, not this one, if I just bring it back, as you can see, it becomes blue again and everything works fine. So pretty much this mono behavior is also part of this Unity engine namespace. Okay, so as I've said, anything that Unity uses is part of this Unity engine namespace. So if we want to use mono behavior, then we need to use this Unity engine namespace, and we're going to write using Unity engine, which tells Unity that we want to use anything that's inside this namespace. Okay, so then Unity will allow us to use anything that's inside this Unity engine namespace, and then we'll be able to use this mono behavior, and then in turn we're going to use all the functions available inside this mono behavior. Okay, so this is the basic structure of the code, and you don't need to worry much about it because this is just the basic thing. This is just the beginning, and I just wanted to give you the basic concept that we have here. Okay, now these things, as you can see in the top, using system.collections, or generic, we are not going to use them in everything. So you can go ahead and delete these namespaces because we don't need these namespaces. Okay, currently we only need this using Unity engine namespace and this mono behavior, inheriting from this mono behavior, and then inside this class we can use any function from the mono behavior and any function that Unity has created for us. Okay, so this was the basic understanding of the very first script that we have created. I hope this video helped you, and I think it's a little bit confusing for absolute beginners. So don't worry, as we go along, you're gonna learn everything and you're gonna understand everything. Okay, so I hope you enjoyed this video and learned something. So thank you very much for watching. This is Raja from Charger Games, and I'm gonna see you in the next videos. Hey there, welcome back to another Unity C# scripting tutorial. My name is Raja, and in this video we're gonna learn about variables and data types in Unity. So let's get started. So in this video we're gonna learn about another feature of C# or in general programming which is called variables. Okay, so the variables, you can think of them as the temporary place where you can store some value. Now, if you want to store the value of score or power or position or speed or anything like that, you need to store that thing inside something, and that something is known as variable. Okay, so in programming, we use variables to store a certain type of value. Okay, so now let's say when we want to store a score, then we can store it inside an integer variable because the number of score, let's say 0, 1, 2, 3 is an integer. Now let's say we want to store the position. Now position is not always in a whole number. It's something like 2.5, 4.5, or let's say speed, which is 4.5 meters per second or 2.5 meters per second or 2.4 kilometers. So things like this are not integer. There we have a decimal point. And again, if we want to store my name, so let's say I want to store my name, which is Raja, or your name, or things like that. So as you can see, there are different types of data or different types of value that we want to store while we are writing our script or for our game. So that is why we need different types of variables to store different types of value. Okay, so let's start by learning the basic integer type of variable. So integer type of variable can store only integer values. So integer values like 0, 1, 2, 3, 4, 5, 4, 5, 6, 45, 25. These things are known as integer without any decimal point. So if we create a variable of type integer, then inside that we can store the values which are integers. Okay, so let's say I create a variable named score. Okay, and inside that score I want to store integer type value. So if I want to make a variable of type integer, then I need to write int before it. So if I write int and then score, that pretty much means I have created a variable score which is of int type, or which is of integer type. So I can store only integer values inside this variable. Okay, So now how we can store values inside this variable? To store value inside this variable, we need to simply write equal sign and then need to write the value. Let's say I want to give the value 10 to score. So I write 10 and then I end the statement with a semicolon. Now in C#, whenever you want to end any statement, in every case you need to write a semicolon to end that statement. Okay, so in every line you need to write semicolon to end anything you have written. So here this whole thing pretty much means we have created a variable which is of name score, which is of type integer, and it has a value 10. Okay, so now anywhere where I want to write 10, I can simply write score, and the score value of 10 will be displayed there. Okay, so let's try to understand it by an example. So let's say inside start function I write print 10. Okay, so as you can see here I have written 10. So if I go back to Unity now, and as you can see here I have my console, and if I click on play, you will see it prints 10 because I have written 10 here. So now let's say in place of 10 here I write score, and now since the value of score which is stored inside this score variable is 10, so again instead of score this 10 value will get printed. So now let's go back here and clear the console, click on clear and then run. And now as you can see again 10 is getting printed. So that means the value which is stored inside this score variable which is 10 is getting printed. Okay, so now let's say we want to store something, a value which is a little bit different. So let's say we want to store a value 2.5. Let's say we want to create a value of speed. So speed equals 2.5. Okay, so let's say we want to store this 2.5 value inside this speed variable. Now we cannot store this kind of value inside an integer variable. Okay, so for that we need to create another different type of variable which is known as float. So remember, whenever you want to store any value like this, then you need to create a variable of type float, and you need to write f after the value. That means we are specifically telling Unity that we are creating a value of 2.5 which is of float type. Okay, so now let's say inside this print, instead of score we write speed. So here as you can see we write speed. So now the value of speed which is 2.5 will get printed on our console. So let's see how that works. So let me go ahead and clear the screen. Here as you can see I have cleared the screen. Now if I run it, now you will see the value 2.5 will get printed, which is the value of this speed variable. Now let's say I write the type of this speed variable an int instead of float. So let's say I write int and then I write 2.5f, and let's return back to Unity, and as you can see it gives me an error. It says constant value 2.5 cannot be converted to an integer. Okay, so we cannot store this type of value inside an integer. If we want to store it, then we need to create a variable of type float, and now everything will work fine. Okay, so this was the basic two types of variable, integer and float. Now we're going to learn another type of variable which is known as a character. So let's say I want to store any character, let's say A, B, C, D, one single character. So if we want to store one single character inside any variable, then we need to create another type of variable which is known as character type. So we can simply write char, and you can pronounce it as char or char, whatever you write. This is short for character. And then let's name the character character, and then inside it we need to write single quotation marks, and inside this single quotation marks we can give whatever value we want to give. Let's say I give the value A, and then end the statement with a semicolon. So this pretty much means we have created a variable which is named character and which is of character type, and inside this variable we have stored the value A. Okay, so now let's say in this case I write character here, and now you will see that the value of character which is A will get printed in the console. So let's clear these things now, and now if I click on play, you will see the value of the character, which is A, it's getting printed here. Now let's learn about another type of variable, which is known as string. Now string variable is used for storing whole names or whole words. Let's say I write my name is Raja or I go to school. So things like this, if you want to display things like this, then we need to create another type of variable which is known as string. So let's say I create a variable named string, and I give the name of the variable name, and inside this we need to write double quotation marks, and inside this double quotation marks I write Raja. Okay, so this is what the value of this name variable, that is Raja. So now in place of this character, if I write name and then here I clear the screen and click on play, you will see that Raja is getting printed here. So that's my name. So these are the different types of variables and how we can store different types of values inside those variables. So there's integer, float, character, and string. Okay, so we have learned all these types of variables by using different examples. So I hope you really learned from this video. So thanks for watching, and I'm going to see you in the next videos. Hi there, and welcome back to another Unity C# scripting tutorial. So in this video, we're gonna learn about this update function. Okay, so let's get started. Now in every game or in most of the graphical applications, you know that there's a concept of game loop. A game loop is something that keeps running and running and running until the game finishes. So the game loop constantly checks for inputs for our player's position move, or it checks for where to render the player, how to destroy the player, and everything. So a game loop actually checks every minute what are the changes that are happening to the game and then renders it on the screen. Okay, so that's what a game loop is. Now in case of Unity, we don't need to create a game loop separately. Unity gives us this update function, which gets called constantly again and again and again every single frame. So anything that we need to do every single frame, we can simply write that inside this update function. Okay, so let's say we need to move our player constantly to the right or left direction in every frame. So we move that code, so we write that code inside that update function so that our player will constantly move to the right direction. Or let's say we need to check for some inputs. Let's say we need to check whether the player has pressed the mouse button or the left mouse button or not. So if we write the code for checking the mouse button, so let's say here we write the code for checking mouse click. So if we write the code for checking mouse click inside this start function, since we know that this start function gets called only once at the starting of the game, so the mouse click will be checked only once. So while playing the game, if we click the mouse, this thing will not be checked. Okay, but if we put the code that checks whether we have clicked the mouse inside this update function, since this update function runs again and again and again every frame, and it runs constantly, so it will constantly check if we have clicked our mouse and if we have clicked our mouse, and when we click our mouse, it will check that. Okay, so anything that we need to check constantly, we need to put that inside this update function. So let's understand it with a little example. So let's say inside start I print calling start. Okay, or let's say I print car move. Okay, and now if I go back to the Unity editor and select the console and make sure this script is enabled on our game object, and if I click on run, you will see that it prints car move, but only once. Okay, it prints car move but only once, and that's because we have written it inside this start function. Now let's say we just copy it from here and put it inside update function, and now if I go here and run it. Now this time you will see that the car move is getting called again and again and again. Okay, so as you can see, we have already called it 300 times. So since the car move is now inside the update function and the update gets called again and again and again, that is why this print car move function is getting called again and again and again. So if we have to move a car from one place to another, we definitely need to put that inside this update function so that the car keeps moving. Okay. Now let's try to understand it with a more visual example. This was just a test with some text. So let's try to understand with some visual example. So let me go back here to the scene. And what I'm going to do is I'm going to create a 3D object and a cube. As you can see, we have this cube in the scene. And I'm going to also go here and click on reset position or reset so that our cube moves to 0, 0, 0. You need to make sure that the position is 0, 0, 0 on X, Y, and Z direction. So now that we have done that, now what we need to do is we need to write our code and we need to attach it to the cube. So let's say inside this code, inside this start function, I write something like this. I write transform.translate. So this is a function which helps the cube to move in any particular direction. Now currently you don't need to understand much about it because we're going to learn about it in later videos. For now, just understand that this is a function that helps us to move the cube from one position to another position. Okay. Now if you can see that the cube can move in X direction. This red one is X. This one is Z. And this green one is Y. So the cube can move in X, Y, and Z direction. And we can decide how much we want the cube to move in X, Y, and Z direction. So let's say in X direction, I want the cube to move at 0.1 f speed. And in the Y direction, I want the cube to move at 0 speed. And in the Z direction, I want the cube to move at 0 speed as well. So this code pretty much means I only want the cube to move in the X direction by this amount. Okay. Another thing we can do is we can simply create a public float speed variable. Okay. And we simply copy the speed and put it here instead of putting a value. Okay. So now that we have done that, now we can go to our code, our Unity editor, and we need to make sure that we have attached this script to the cube so I can drag and drop it to the cube like this. And as you can see, now we have this position of the speed where we can put any speed and the cube will be moved by that speed. So let's say here I write 0.1. Okay. And as you can see here, the position, the X, Y, and Z of the cube are 0. Now if I run the game, you will see that the cube will slightly move to the right and the position of X is now 0.1. Let me do it one more time. As you can see, the cube is here. You will see that the cube will slightly move to the right. So if I run it, as you can see, the cube slightly moved to the right and the X position changed from 0 to 0.1. Okay. Now as you can see, this is happening only once, because we are calling it inside the start function. Now let's say I just copy it and put it inside update function. Okay, the same thing inside update function. And now if I go here, and you need to see that we have this 0 here as well. And if I run it now, you will see it will constantly keep moving to the right direction and the position will be updated by 0.1 again and again and again. So that means the same thing that was happening in the start, the same thing is getting called again and again and again because we are calling it inside update function. So that pretty much means that update gets called again and again and again in each and every frame. So anything that we want to do again and again and again, we need to do that inside update function. Okay. So I hope your concept about the update function got cleared. We're going to learn more and more about this in later videos, and you will definitely understand if you have some confusions about this update function. So thank you very much for watching, and I'm going to see you in the next video. Hey everyone, this is Raja from Charger Games and welcome back to another Unity C# scripting tutorial. So in this video, we're going to learn how we can create our own custom functions. So let's get started. Now previously you have heard me saying that this is update function and this is start function, and you don't yet know what the function is. So in this video we're going to learn how we can write our own custom functions. These things are the functions that are already created by Unity and we are reusing them. But in this video we can actually create our own functions and we're going to learn about different methods of doing that. Okay, so let's get started. Now before that I'm gonna say another thing that you are probably seeing for some videos but you don't know what that is. So as you can see, these things here, these things are known as comments. So in your code you can write comments just for the sake of understanding, but deleting them or having them actually makes no difference to your code. So they don't really take any effect in your code, they are just for understanding or they are just for clarification. So if you want to write any comment at any position of your code, you just need to give 2 forward slashes, and then if you write anything, as you can see it becomes gray already, that means it has no effect. Another way to write comment is by writing a forward slash star, then a star again, and another forward slash. Now anything if you write inside will become a comment. Okay, so when you want to write a short comment you can use this thing. When you want to write a long comment, you can use this thing. Okay, so this was just for understanding. Now let's learn about functions. Now functions are something which you can consider as a block of code. So functions are a place where we can put a lot of code together, and whenever we need them we can simply call the function instead of calling all the codes. Okay, let's say inside this update function we have a lot of things to do. Or let's say inside the start function we have a lot of things to do. Let's say we print shoot, we say, after that we may wanna say print move. So let's say we are in our game and we want to do all these things, and let's say after that again we want to do transform dot translate our object by speed and 0 and 0. So let's say we want to do all these things and we are writing it inside start function. Now let's say we want to do all the same things inside this update function as well. Or let's say we have another place where we want to call these same things. Or let's say inside the start function we want to do these things again. So what we need to do is we need to copy all the code and write it here one more time. And if you want to call it from update, we need to copy all the code and write inside update one more time. Let's say we want to call these things 1000 times. Then we need to copy all the whole code and copy it to 1000 times. Here I have given an example of only 4 lines, but let's say the code is of 100 or 200 lines. Then what we can do is we can actually put the whole code inside a function, and then whenever we need to call the code we can simply call the function and we don't need to write all these things. Okay, so what we can do is here, let's say we write a function and inside the function we simply put all the code, and then instead of calling all the code we simply call the function. Okay, so let's see how we can actually write a function. To write a function, first of all we need to give a name. So let's say I give test function just as a name, and after that we need to give a pair of parentheses and then a pair of curly braces. So this is the basic syntax of a function: the name of the function, a pair of parentheses, and a pair of curly braces. And anything inside this is the body of the function. Okay. Now another important thing that a function has is, as you can see here, we have this void thing written in front of these functions. So another thing that a function has is known as the return type. So every function has an ability to return us something. So let's say we are creating a mathematical function from which we want to get the square root of a value. So in that case we need to get an integer because square roots are an integer. Let's say we have a function which gives us how much distance you have traveled. So there we need to get a float as a return. So whatever we want to get return from the function, we need to add it as a return type of the function. Let's say here we give int. That means we can only return an integer value from the function. Let's say we give a float. That means we can only get a float value as a return from the function. But let's say from a function we don't want anything to return. We don't want anything in return. We simply want the function to do something and just go away. We don't want it to return us anything. In that case, we need to write void in front of it. So if we write void in front of the function, that pretty much means we don't want that function to return us anything. As you can see here, the start and update functions don't return anything. That's why their return type is written as void. Okay, so now let's say I simply cut this code and move it inside this test function and delete this one as well. So now whenever I want to do all these things, we don't need to do all these things. We can simply copy this part and write it here and put a semicolon. So this is how you call a function. So writing this pretty much means that I am calling all these things. Okay, so instead of writing all these things, I can simply write this and the function will be called and all these things will be executed. If I want to execute it multiple times, I can simply write it multiple times. So every time the function will get called, all these things will happen. I can even call it in update function and all these things will happen as well. Okay, so let's test it. Let's say inside the start function, I just call this thing. So this thing will be executed and all these things will happen. That means first it will print shoot, then it will print destroy, then it will print move, and then it will transform the object, then it will move the object by 0.1 on the right side. So let's go back to Unity and see how it works. So let's go back to the console, clear it, and if I run it now, you will see first it prints shoot, then it prints destroy, then it prints move, and then it moves our object by 0.1. Okay, so that's what is happening here. So as you can see, instead of writing all these things, if I simply write the function, the same thing happens. So let's say instead of writing the function, let me comment it out, and now if I write all these things instead of writing the function here, I can simply copy these things and write it inside start, and if I go back to Unity and clear it, and now if I run it, you will see the same thing happens. Okay, so whether we call it directly or we call it through a function, the same thing happens in both of these cases. Okay, so this is the concept of functions, by how you can create a function, how you can return something or don't return something from a function, and why we need a function. So I hope the concept of functions got cleared. So in the next videos, we're going to learn about more details about functions, how we can return something from the function, and how we can give inputs to the function or give parameters to the function. So I hope you really enjoyed this video and learned something. So thanks a lot for watching, and I'm going to see you in the next videos. Hi there and welcome back to another Unity C# scripting tutorial. My name is Raja, and in this video we're going to learn about if-else statements in C# scripting. So let's get started. So we have learned about functions, we have learned about different event functions of Unity. So let's learn about if-else statements. So before actually we take a look at the syntax, let's learn why we actually need it. So we need if-else statements for checking conditions. And you know that whenever we are playing a game, whenever we are building a game, we need to make decisions, and we need to check decisions and check, we need to check conditions every time. So let's say we need to check whether the score is below 0, then we need to say game over. If the score is below 100, we need to give an award to the player. If the game is above 500, we need to say you have won the game. So this way we need to check for actually different conditions to do different things in our game. We also need to check if the player is pressing the left arrow key, then we need to move the player to the left. If the player is pressing the right arrow key, then we need to move the player to the right. So this way we always need to check some conditions to do some things in our games. So to do that, we need to use the if-else statements. So let's say we write the if-else statements inside this update function. Okay. So the syntax to use if-else statements is, first of all, you need to write if, then you need to write a pair of parentheses, and then it's a good idea to write a pair of curly braces. So this is the body of the if statements. So whatever we write inside these curly braces will be the body of the if statements. And inside this, inside this parentheses is where we have the condition part. Okay, so this is where we have the condition that we need to check. And inside this body is where we need to execute if condition is true. So if this condition, whatever we have written here, is true, only then whatever we have inside this body of the if statement will get executed. Let's say inside this we write print game over. Okay, so it will print game over only if this condition is satisfied. And what is this condition? We can give different conditions here. Let's say here I create a public variable, public int score. Okay, so I create a variable named score, and inside the condition, let's say I need to say if the score value, or if the value of score is below 0, then we need to print game over. So the condition, we can say if score less than 0, then print game over. Okay, so this if statement will check if the value of the score variable is below 0, or here we need to say is less than equal to 0. So that means if the value of score is 0, -1, -2, -3, -4, and all that. So if it is equal to 0 or less than 0, then it will print game over on our console. Okay, so let's go to Unity editor, and you will see that we have a variable here now. So it's score. So as you can see the value of score is 0. So let's make it 5 and now run it. And you will see this time nothing is getting printed. But now if I give the value of score to 0 and then run, you will see it prints game over again and again because we are calling it inside the update function. Okay, so we can also call it inside the start function at the beginning like this. So it will simply check if the score is less than 0, then it will say print game over, and if the score is not less than 0, then it will not do anything. So there we have another opportunity. So if the score is less than or equal to 0, then we know what to do. Then we know that we need to print game over. But what if the score is not less than 0 or equal to 0? Then what do you do? So for that we have this else block. So this thing is known as the if block, and if it is not true, then we need to do something that's called the else block. So we need to write else, then a pair of curly braces, not like this, a pair of curly braces, and like this. So if this condition is true, then this thing will happen. Else, that means if this condition is not true, then these things will happen. So inside else I can say print game running. Okay, so when the score is less than 0, it will say game over. When the score is not less than 0, it will say game running. Okay, so now let's go back to Unity and see how it works. Okay, so as you can see here, the score value is 0 now, and if I run it quickly, it will simply print game over. So if I click it, and if I give the value of score 5 and then run it, now you will see it says the game is running. Okay, so depending on the condition, depending on the value of score, it is checking the condition, and then it is executing either this block or this block depending on the condition. If the condition is true, then it prints this one. If the condition is not true, then it prints this one. Okay, So we can use this if statement for various things. Let's say we can check whether we are clicking the mouse, whether we are touching a player, whether we are moving to the left, whether our velocity is less than 0, whether we are moving to the up, whether we are moving to the down. So anytime in our game, if we need to check some conditions, we can use this if statement to do that. We're gonna learn more and more about these if statements in later videos and how we can check different conditions. But in this video, we're gonna learn just the basic syntax and how we can use the if statements. Okay. Now, since we have learned about if and else, there's something more that we can do. So let's say whenever the score is less than equal to 0, we are saying game over, and when it is greater than that, we are saying game running. Now let's say we want to give more conditions. Let's say when the score is above 10, we want to say you are on level 1. When the score is above 100, you want to say you are in level 2. When the score is above 200, we want to say you are in level 3. Currently our code, what happens is whenever the score is greater than 0, it simply prints game running. But here inside the else, we cannot give different conditions. So if we want to give more than one condition, if we want to check more than one condition, then we need to use something that's called else if. Okay. So whenever something else happens, then we need to check another condition. So let's say if the score is less than 0, then it will do this. Else if, that means if this is not true, then it will check this one. So else if, let's say if score is greater than 10, or let's say if the score is greater than 0, then it will say print level 1. Else if score is greater than 10, it will print level 2. Okay. So here what is happening is, first of all, it is checking if the score is less than 0, then it is saying print game over. Then it is checking if the score is greater than 0. First it is checking if the score is less than 0, then it prints game over. If the score is greater than 0, it says level 1. If the score is greater than 10, then it prints level 2. And else, when nothing happens, it says game is running. Okay. So first it will check if this is true. If this is not true, then it will check if this is true. If this is not true, then it will check if this is true. If none of this is true, then it will check this one. Then it will do with this one. Okay. So when we are writing else if one condition gets satisfied, the next one will never be checked. So if this one is satisfied, let's say the score is greater than 0, then it will never check if the score is greater than 10 or not. And if this one is true, it will never check if this one is true or not. Okay. So now let's go ahead and see how it's working. So according to our condition, if the score is less than equal to 0, it should print game over. If the score is greater than 0, it should print level 1. If the score is greater than 10, it should print level 2. And else it should print game running. So let's go back to Unity and see how it's working. Okay, so as you can see, currently the score value is 5, which is not less than 0. That means it should not print game over. Which is greater than 0. That means it should print level 1. And as you can see, it prints level 1. Inside our script, we have written that whenever the value of score is greater than 10, then it will print level 2. But let's see if it works or not. So here, as you can see, in place of 5, now we're gonna give the value 10. And if we run it, as you can see, it still prints level 1. So previously we said that it has when the value was greater than 0, it should print level 1. But when the value is greater than 10, it should print level 2. But here it is still printing level 1. Why is that? As I've said, in else if statements, when a condition is true, it will never check for the next condition. So as you can see here, we have given the value of score 10. So we have given the value to score 10. So first of all, it checks if 10 is less than or equal to 0. No, it is not. So this is not executed. It moves on to the next condition, which is this. If score is greater than 0, if 10 is greater than 0. Yes, 10 is greater than 0. So since 10 is greater than 0, so this condition is satisfied and this thing gets executed. That is, it prints level 1. So since 10 is greater than 0, so this thing gets executed and these things are never executed. Okay. So though the score is greater than 0, it also satisfies this condition that the score is greater than 0 as well. So that is why it is printing level 1. Okay, so okay, actually I did something wrong here. I have given 10 here, so let me give 15 here and run it. And you will see again it prints level 1. So 15 is greater than 10. So what I'm trying to explain is 15 is greater than 10. So it should print this one, level 2, but it is still printing level 1. That's because 15 is not only greater than 10, it is also greater than 0. So the first condition is getting satisfied. That is why this is getting printed and this is never getting checked. Okay. So if we want to check one condition and we don't want it to be executed on other conditions, then we need to add multiple conditions together using AND OR operators. Okay. So here, as you can see, we can say that if score is greater than 0, then level 1. And here we can say if score is greater than 0, and we can give this sign, which means AND. So when we want to join two conditions, we need to give this thing, which is known as the AND operator. So here we can say if score is greater than 0 and score is less than 10. So this is one condition and this is one condition. And then we are joining both of these conditions together. So this else if block will now check if the value of score is greater than 0 and it is less than 10. Only then it will print level 1. Okay. And this one will check if the score is greater than 10 and then it will print level 2. Okay. So here I have saved the script and let's go back to Unity now. And previously, as you have seen, that when the value 15 was given, the level 1 was getting printed. But now if I run it, now you will see it prints level 2. Okay. And now here if I give the value 5 and then run it, you will see now it prints level 1. Because when we give the value 5, the value of this score is 5. So first it checks if 5 is less than or equal to 0. Is 5 less than or equal to 0? No. So this thing is not satisfied. So it goes to the next condition, which is this. 5, is 5 greater than 0? Yes, 5 is greater than 0. Is 5 less than 10? Yes, 5 is less than 10. So 5 is greater than 0. So 5 is greater than 0. And 5 is also less than 10. So both of these conditions are satisfied. That means both of these conditions are satisfied. So that is why this is getting printed. But when we are writing 15, then 15 is greater than 10? Yes. But is 15 less than 10? No, 15 is not less than 10. So both of these conditions are not getting satisfied. So that is why when we are giving the value 15 to the score, both of these conditions are not getting satisfied and it is not getting printed. Then this is getting printed because 15 is greater than 10. So it is printing level 2. Okay. So this way, by using if, else and else if statements, we can create complex conditions that we can use in our game anytime. We can use it to check scores, points or levels or health, or to check inputs, outputs, anything. Okay. So using this if, else, if statements, we can check conditions and we can use them efficiently in our game. So let me summarize it one more time. So here what I've done is we are first checking inside if we are giving a condition and we are checking if it is true. If it is true, then this thing gets executed. And inside else if, we check other conditions that we need to check. So inside else if, we check the condition, and if it is true, then this happens. And if the condition is true, then the next one never gets checked. Okay, so the first condition that is satisfied will get executed, and the next one will never be checked. And finally, if none of the conditions are satisfied, then this else block runs and it prints whatever is inside it. Okay, so if first checks the condition and does that, and then else if checks the next conditions, and if none of these are satisfied, then the else block runs and this thing happens. Okay, so I hope the concept of if, else if and else statements got clear. Later on, when we're gonna use them in our games more and more, these concepts will get clear more and more. This was just the basics to give you an idea of how these things work. So I hope you really enjoyed this video and learned a lot. So thank you very much for watching, and I'm gonna see you in the next videos. Hey there, thanks for watching this Unity C# scripting video. I hope you really enjoyed and learned a lot throughout this video. So this video is part of my complete Unity C# scripting course, which is a 25+ hour long video course, and there I discuss about these topics in a lot more detailed way. There I'm going to teach you a lot more things, and there I'm going to teach you object-oriented programming concepts, more about Unity's core scripting API, and there you will also build 2D as well as 3D complete games from start to finish. So if you enjoyed this video and if you want to take the course, make sure to check the link in the description where you get the link to the course, and you can take the course and learn more about this Unity C# scripting. So thank you very much. If you like this video, make sure to give it a like and subscribe to my channel for more such cool videos in future. So thank you for watching, and I'm going to see you in the next videos. Make sure to check the links in the description to get enrolled in my complete course. So thanks for watching, and I'm going to see you in the next videos.